Here, an experiment was performed using various lengths of a conductor uniform cross-sectional area. The resistance of each length was measured and the data recorded in the table below. Using the information in the data, construct the graph on the grid provided in your answer booklet. Follow the directions below. Mark an appropriate scale on the axis labeled length M. Alright, so they just want us to create a graph. Resistance versus length. That means whichever one they say first in this right here, resistance versus length, that means resistance is going to be in the y-axis, this is going to be the y-axis, this is going to be the x-axis. So the y only goes up to 7.5. You know, I can make it count by 1s all the way up to 8. This one goes up to 23. I can make it count by 5s. Yeah, I can make it count by 5s. So let me make this graph over here. 8, 9, 7, 6, 5, 4, 3, 2, 1, 0. Okay, that's the first one. I'll just divide this into 5. So. Mami, estás en un video. Excuse that. Excuse her. 1, 2, 3, 4, 5. 1s, okay. Alright. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So the y is going to be the resistance ohms. So let me write that. Ohms. The bottom is going to be length meters. Okay, I said I was going to come by 5, 5, 10, 15, 20, 25. Okay, 5.1, the resistance is 1.6. This is about 5.1, you know, very close to the line. The resistance, 1.6. No, about halfway. 11.0. 11.0, the resistance is 3.8. Whoa. Yeah. No, wait. 1.6. I don't know where I got 5.1. Ignore this dot up here. When it's at 5.1, the resistance is 1.6. Up here. Length is 11, resistance is 3.8. About there. Length is 16, resistance is 4.6. About there. Length is 18, resistance is 5.9. 18. About there. Length is 23, resistance is 7.5. It's gonna be halfway. So 23, a little bit less than 25. Okay. So line of best fit would be like, just draw a line from here to there. Okay, that would be the line of best fit. Okay, they asked for the line of best fit. I just drew it. What else? Actually, let me just go all the way down. Okay. What are they asking for? Calculate the slope of the best fit line. Show all work, including the equation and substitution units. Okay, so we can use these coordinates here. So, for slope, it's rise over run. So rise, it means the change in the y values over the change in x values. So I'm going to use the first two coordinates. So y 1.6 3.8. So wait, let me write the given x1 equals, so the first x is that we're using is 5.1, x2 is 11.0. Now going with y. The first y is 1.6, the second y is 3.8. Equation, slope is change in y over change in x. All that means is y2 minus y1 over x2 over minus x1. So let me write that. So let's fill it in. Y2 is 3.8 minus, oh, okay, let me write the units actually. So ohms. Okay, I'll do that right now. Ohms minus 1.6 ohms. Okay, now x2 is 11. That's meters. Minus x1 is 5.1 meters. So 3.8 minus 1.6 is 2.2 ohms over 11 minus 5.1 is 5.9 meters. So 2.2, let me do them. 2.2 over 5.9, let me do the math. 2.2 divided by 5.9, 0.32. So 0.32 ohms. So this is the symbol for ohms, something like that. Okay, ohms per meters. All right, this is not a 0. Let me redraw that. All right, something like that. So that's 72. So all right, that's 72. Now I'm looking for the answer. Where is this? 72. Okay, we got the slope was 0.32 ohms per meter. Right here, 0.32 ohms per meter. And let's see their graph. That's their graph. Okay, they counted by fives. Counted by, I don't know how much. 1, 2, 3, 4. They counted by 0.2 each box. By 0.4 each box. Anyway, yeah, that's their graph. My graph, yeah, I didn't have graph paper, so. Well, the answers are correct anyway. So